Yes, let's start. Welcome, welcome everyone. As you know, last time we did not get through the entire module 1, so Stanislas is picking up from that one this time. Just a brief info. As you know, we are recording. We will share a recording of the first 3 modules with you all on Friday. Whenever you have a question, just raise your hand or write in the chat. Okay, Stanislas, please.
Very good. Thank you, Marianne. Good morning, everybody. I'll let you admit people as they come, right? Yeah, yep. Very good. Good morning, everybody. Salam alaikum. My name is Stanislas. You can call me Stan. I've been working with solar PV for the last 15 years or so, and I will so. The session of today is focusing on site surveys and pre-design, but I will first go through the last session of the last part of the last session, the mounting systems, which we didn't have time to cover last time. Again, if you have any question, please raise your hand. Feel free to interrupt me. I want it to be interactive. So yeah, let's go. I will turn off my here we have one question, Engineer Mahmoud. You have a comment or a question?
Please, just for a few seconds, I want to every member in this course to open them webcam, okay? Because we want to take a view for the work of public relations, okay? نعيم.
Sure.
ممكن تعملوها في نهاية السيشن يا باشمهندس، عشان كان عندنا ضغط في الوقت المرة الماضي، فخلينا نغطي قدر الإمكان وفي نهاية المكالمة ممكن نعملها.
It's okay.
So Stan, it is about taking screenshot for everyone while opening the camera. So I just told him we can make it at the end after we finish today's session.
Okay. Yeah. As you wish. Very good.
Yeah, go ahead.
I will remember that.
Yeah, go ahead.
I will turn off my camera then, so it focuses on the presentation. Here we go. So we covered in the last session, we covered the introduction of solar PV, we covered the modules, we covered the inverters, and now there is another part which is quite important in planning solar PV, that's the mounting system. And by that, we mean everything that is dedicated to mount the PV modules. So that's the whole structural framework that puts the PV module either on a roof or on a ground-mounted structure, and that ensures that it's going to stay there for the years to come. We're usually planning for 20 or 30 years lifetime for the PV plants, and it's going to resist to whatever kind of environmental condition, being wind, snow, rain, earthquakes, I mean, whatever. So we're going to differentiate several kinds of solar PV plants. The first one will be roof mounted. So it's how we put it on roof, either on residential houses or on commercial rooftops, which are usually flat. And then the ground-mounted system, which is all the systems that are used to put the modules on the ground. As the name says it. We will also cover very quickly the tracking systems. I will just mute. The tracking systems that follow the sun, and I will come back to that. There is one additional system which is not here, which is a bit of a niche, but it's a floating system. So it's also possible to use some kind of floats to mount the PV panels on top of it and put it floating on water, usually on inland water, so like water bodies for irrigation or stuff like that, not really on the sea yet. Okay, so what does it look like? For the flat roofs, we usually have this kind of system. I will try to share also my pointer. Go. So these systems are usually have a small slope and small height installation to avoid too much wind catching. So that's why they also closed on the other side. But you can also install more more inclined structures on flat roof. So we won't go into details of that. It's again to provide some kind of understanding of what's available and what's possible. These ones are covering the flat roof in there, and they're usually ballasted. So it's just a ballast system that allows for the structure to stay in place during high winds and stuff like that, for example. On the inclined roof, you will find a lot of different solutions for all kind of roofs, all kind of tilt, of angle. It's usually kind of the same with some kind of clamps that you install either on your roof structure directly or on the roof cover for this kind of metal sheets in there. And then you have some rails that come to on the clamps to kind of build some kind of grid on which you put the panels with also clamps in there. So it's quite simple. A lot of different solutions. Some of them are waterproof, some of them are not. All kinds of solutions to also fix it to the roof. The market is full of different providers for that. So that was roof mounted. In here, we will focus mostly on the ground mounted PV plants. And for that, you have different types of foundation. The first one here is what we call the concrete foundation. So that is just columns that are anchored into concrete footing. So you pour, you dig, you pour concrete in there, and then you have the pile that is going into the concrete. It is very good for very permanent installations because it's highly durable and very stable, but it is very costly, and the installation time is also quite high. So it's something we don't see very often, but it's a very robust solution. An alternative to this one is a driven piles. So these are steel piles that are driven directly into the ground using hammers, huge industrial hammers. Are you still seeing my screen? Nope, I think here we go. Yep, someone took control of my presentation. Yeah, so these are steel piles. It is very, very fitted for very large scale projects because when you have the equipment to put the piles into the soil, it can go very quick. So it's very fast to install. There is no concrete required, which is also very good, but it can be tricky for rocky or very soft soils. This is usually the preferred solution when feasible for large scale projects, driven piles. Then you have another option for more tricky sites, which are the ground screws. These are huge screws that are drilled into the ground. It's pretty good for uneven terrain. Also no concrete, so it's also quite an advantage when during the construction phase. But it requires specialized equipment. It's also often a bit more costly. So it's for kind of untypical soil conditions. And then the ballasted system, which is kind of self-explanatory. So it's a huge concrete block that is used as a ballast. It's very heavy. It's good for rocky terrain or areas where you can't dig because of the underground solution. So there is no ground penetration, which can be an advantage depending on what you have under. It's also quite easy to remove at some point. But of course, it requires a lot of concrete, and the construction time is also a bit impacted. So these are the four main typical solutions for ground-mounted PV plants. In terms of modules then, because this was the foundations, you can have different solutions in there too. You can have a single row of modules, for example, which is quite easy to build and can also adapt more easily to uneven ground, as you can see in there. Even if now, even several rows of modules can also adjust with a new mounting system solution that we have in the market now. But then you can go up to 3 or 4 or even 5, either in portrait or in landscape. So that's things you have to check with a mounting system provider. But usually this huge table, as we call it, are mostly fitted for huge plants on the flat ground, like you see in there. And then you have also different solutions. You actually have a solution for everything, just a question of costs. But the market is fully mature, and whatever the restrictions you have on your site, there is a solution somewhere. So it's just a question of costs. But like this plants with higher elevation and the ballasted system, it can be quite interesting for PV plants where you don't want to impact the floor level too much, for example. This is also feasible. And then you repeat it. So like this is an example of a microgrid group where you have 3 modules in a landscape orientation, and then you repeat it. This is quite heavy. You have a lot of ballast. You have like 4 blocks for 3 modules. But depending on the location, depending on the wind conditions and everything, it can be a solution also there. Sure, I can raise my voice. Can you hear me? I hope you can hear me well. Yeah, so that's a short introduction to the foundations and mounting systems. Is there any question on that? Now, please. Engineer Mahmoud, I think you have your hand raised.
Yes, it stands.
Yes.
I want to know which is the best module which we can implement here in Gaza Strip. You know that we try to customize these solutions to be fit to our situation here in Gaza, and so you know that we don't have enough land, okay, due to the tenants which are around, and so we try to find a customized solution. Which solution is the best for our case from your point of view?
Yeah, there are different options. Of course, the roofs or the buildings is one for the buildings that are left standing. When it comes to ground mounted, one solution which is not presented in there is east-west configuration, where instead of having your modules facing south, you have 2 rows of modules, one facing east and one facing west. So you cast less shading from one row of module to the other. I think Michel will come back to that tomorrow during the design module. You might try different solutions and different orientation and see the impact on the energy generation. But one main advantage of this kind of solution is also to optimize the ground use. So you have more installed power per square meter, which is a good thing when you're limited in ground use. So that's one. And another one, which is also quite a hype now in different markets, is what we call agrivoltaics. So that's also solar PV module mounting systems that are much higher in terms of elevation. That also allows for using the ground below to do agriculture or crops or catering or whatever. So you can have sheeps under the modules and everything. And that also allows for dual use of the land, which is a good thing when you're limited in there. So I hope it answers your question.
Yeah, just to chip in there, and maybe Naeem, if you want to elaborate, but in the technical report, There is a description of like easy to make structures, so the solar panels can be installed above tents.
Yeah, that's true. Actually, for the other initiative that's going on by the design team, they considered customized solutions, especially for Gaza and current situation, where they considered solar systems using elevated structure to be installed above tents. So they keep using the land, they keep having the tents as it is, and they install solar systems above it. So that one will be shared later on by the technical team with JITCO. So it is there with the structure analysis and the technical reports.
Yeah, very good. There are also solutions to integrate directly flexible solar PV modules on tents, for example. I don't know if it's covered by the report, but that's also an option. Yeah, there's another question here.
Yeah, thank you very much. It's not really a question, maybe just a way to answer to the question in terms of gas. How will you install the maybe add a little of inputs? Maybe, for instance, as we know that Gaza is actually it's a war place right now, and then for this kind of zone, it's also suitable to have a kind of moving system, a solar PV system that is movable, like kind of foldable. If you can have a structure by which it can be moved from one place to another, and it will avoid you, first of all, to have a fixed system which can be destroyed easily. And secondly, also you can move it and you can fold it, and you can transport it as well. So in this kind of zone, having those kind of systems is more suitable than having a fixed one. So that is actually one of my contributions. Thank you.
That's absolutely true. And you have several systems that are, for example, containerized also. So you just deploy the mounting system with the pre-connected modules and inverters and everything, but you can also kind of redeploy it if needed. So you just pack it up again, move it and redeploy it somewhere else. That's also an option. Very good. Well, let's keep going then. The next part is about what we call balance of system. So again, we covered on Monday modules, inverters, now quickly the mounting system. Everything else in a solar PV plant is called balance of system, BOS. And that includes the cabling and wiring. So the DC cables connecting modules together in strings and going to the inverter, but also the AC cables going usually from the inverter to the transformer or directly to the grid connection point. But also the communication cables for the SCADA system, the supervisory control and data acquisition that monitors the whole operation of the PV plant, and the earthing cables for electrical safety. So all cables and wires in the plant are included in the BOS. We also have combiner boxes and junction boxes. I don't remember if it was covered in the introduction on Monday, but for big plants and with like central inverters or bigger string inverters, then you use combiner boxes to just limit the number of cables going to the inverter from the solar arrays, for example. And junction boxes, combiner boxes also included in the BOS, and that includes overcurrent protection and other kinds of electrical protection. And the monitoring system, as mentioned, is also included in the BOS, both hardware and software. Usually what's included in there is a weather station. So you would measure the irradiation, you would measure the wind speed. I'm just gonna try to mute people in there. Here we go. Yeah, so you would measure wind, irradiation, temperature, both ambient temperature and the module temperature, as mentioned by Michel on Monday. and put all that in a huge data log to ensure good operations and performance of the PV plants. But the monitoring also usually includes safety of the plant. So that could be cameras, could be also some kind of sensors on the fence if needed, and all of that. So that's just monitoring the whole plant. And then all protection device on the AC side. So the switch gear, the protection device, the fuses, circuit breakers, disconnect switches, everything before the transformer. Energy storage is an optional one, but that's also included in BOS. The BESS, the battery electricity storage system, and the transformer for large systems. So we usually include transformers in the plant for some kind of larger systems, either stepping up from low voltage to medium voltage for some kind of midterm transportation of the energy, or directly to high voltage also for big plants for direct integration to the grid. And I will come back to that in the next slide deck. Any short question on that, on the balance of system? Anything missing? I think we're good. That was quite short. Great, and we had a small, very small part of the presentation on the tools for the installation of solar PV plants. I will go very fast on that. Nothing really heavy when it comes to the tools required, but just to remember the electrical tools, so the multimeter and everything for testing the plant on the DC side and the AC side before connecting. And there are a lot of standards on that, and that will be covered in different sessions later this week and next week, on details on electrical safety and all of that. That's good. That was the last part of the Monday session that we didn't have time to cover. Any question on session 1, if I may? So that both what we discussed on Monday and what we discussed just now. Anything that wasn't clear? Are you good? You understand solar PV now?
It's good until now.
Yeah, thank you. Okay, very good. Let me jump to the next one then. Yeah, here we go. So here's the actual session of today, the site survey and pre-design preparation. So the idea of this session is to just give you some inputs on site survey and what would be required to assess which sites would fit better than another for solar PV plants, and just to pave the way to tomorrow's session, which will be led by Michel, about the design of PV plants. And a reminder on that, I think the link was shared, but the idea for tomorrow is to use a software called PVSYST, for which you have a free trial period of some days. So I really recommend you to try to get it today and to install it and have it ready for the tomorrow session. And I think if not, Michel will also support you with that. Michel, did you want to add something? I saw that you raised your hand for a second. No, just confirming. Just so we don't lose time tomorrow, so you have it ready to use, and you can start trying it if you want. But Michel will cover that tomorrow.
Thanks. I will post it in the chat now as well. And there's a question
Awesome.
in the chat, Stan. What is the estimated area required to produce 1 megawatt of solar power?
Yeah, there's something wrong in this question. Can someone point it to me? How do you produce 1 megawatt of solar power? You would produce 1 megawatt hour of solar power, but megawatt is a power, not the energy. Depends a lot, and that's also something that we will cover in details probably tomorrow with Michel. But you will see that different equipment leads to different installed power and different efficiencies. like the modules, but also the way you install it. So the way you design your mounting system and you fit it to your required area. So there is no one answer for that. It's more complicated than that, but everything will be clear at the end of all sessions. We're just slowly getting there in a way. Yeah, so the content of this presentation is just a short intro on site assessment, the different site surveys that would be required, some on site viability and shading, and at the end we will just cover quickly the equipment choice, which will partly answer this question. But just the first intro on site assessment. Here we go. So the site assessment, as we call it, is just an exercise which is crucial to assess the general conditions of the site. And when I say site, it can be a ground-mounted site or a building or a rooftop in a way. The viability of the site for solar PV power, because it's not like all sites or all buildings are suited to welcome solar PV modules. Then we will discuss a bit the productivity of the plant, so the energy generation, which is very much linked to the site also, the shading that impact it, the conditions for the grid connection, and the permitting, which is also sometimes quite a huge showstopper when it, especially when it comes to ground mounted. The site surveys. So what are they? It's a couple of technical documents or technical studies that you will have to do before mounting or before going into detailed design of a solar PV plant. There are three main ones. The first one is what we call the topography. So it's a way of mapping your site, mapping the areas of your site, and also the vicinity, so what's in there and what's around. The main topics to cover there are first to have a clear idea of the boundaries of your site. So where are the actual boundaries, the cadastral boundaries when it comes to official boundaries, but also the technical ones, if you have forests around or mountainous terrain or stuff like that. You will also want during topography to kind of map and point every kind of physical feature. Could be fences, roads, buildings, trees, water bodies, rivers, whatever. But just have a very precise idea of where it is, how big it is, and if it changes in time, for example, for rivers. But also what's underground, so mapping if you have pipelines or cables or other stuff underground could also be linked to kind of old architectural things or stuff like that would be kind of protected, for example. So that would limit your impact on this part of the site. And the final one is having an understanding of the elevation of the site, so the contour lines, the steepness of the site and its different hills or mountains or whatever is in there. And additionally, if available, you could have a satellite overlay for that. The outcome is usually some kind of CAD drawing or a GIS map or Google Earth layer or stuff like that. And again, the level of detail can be adjusted to the location and what's available. So it can be quite easy with just pointing on Google Earth different things if you don't have time or budget for that. Or it can be a complete study delivered by a third party with a 3D model, for example. So it really varies a lot depending on your business development requirements and what's available and the timeline you have also in there. I'm just checking the questions in the chat. Okay, that's good. So that's the first one. That's the topography, and that's going to help you in deciding where you put your modules and how you put it. The second one is the geotechnical study. Everything is in the name. So the main idea is basically to understand the underground and what kind of foundation solution will be the most suited for your plant. The method is usually a site visit and borehole. So the dedicated company would just dig and do test pits, for example, to see the underground and do measurements. And then there will be an analysis of the rock, of the soil, and of the water underground. The study should at the end come with some information on the compressibility of the underground, the soil classification, what kind of soil it is, the stability of it, the moisture content, which also be linked directly to the soil resistivity, which will impact the design of your underground trenches and cables, for example. The corrosivity rating, the erodibility, everything to kind of get an idea of how it is now for the design, but also how it's going to be in time and how it's going to be impacted by different weather events like floods or rain season or stuff like that. It also includes a geologic and seismic classification, also just to get an idea of the risk of this specific site compared to others, for example. And as an example, the companies could do, for example, boreholes 5 meters deep, different locations in the site, plus some test pits to get a full idea of the underground conditions. When we design huge sites like several hundreds of megawatts, it's very important to do it spread around the sites because it can actually vary from the northern part to the southern part, for example, when the site is very big. Another thing that can be done is the pile testing. As I mentioned before, the driven piles is one of the most common way of foundations for the ground-mounted systems, and the pile testing is just pushing a pile in the ground and then test it with a special equipment test to just try to pull it out and just measure the amount of force that is required to pull it out and check it against the weather conditions on that side. And if it's okay, it provides confidence that the piles will be there in time. So yeah, geotechnical reports usually also provide recommendations on ramming, drilling depth, for example. Is 2 meters going to be enough? Should it be 3 or 4, given the wind speed of this dedicated site, for example? So that's this kind of recommendation that is included in the geotechnical report. And the same with like road constructions, trench constructions, and the need for drainage, for example, systems and stuff like that. And then the third one of the 3 is the hydrology report. It's also usually a site visit and some data collection, historical data. And the study will cover the land use and the hydrological features. So like compared with rainfall data, try to assess the risk for flooding, but also just terrain erosion and stuff like that in time. And that will also conclude on the design storms for the return period. So should it be the biggest storm in the last 10 years, 25 years, 50 years, 100 years, that's going to be a big difference usually. So yeah, so that's an analysis of the flow rates around, but also underground, and the quality of the water and how it might impact negatively the plant in time. The outcome is usually also a full report for use for risk assessment and some recommendations also on drainage and erosion control measures. On that, any question on the site service? Yes, Mr.
Yeah, I just wanted to add something on that. Also, it is really important to look at the past history of the site, to try to get the maximum data on the history of the site, whether there was a high storm that happened in that area, huge rain in the past. So it's also important to collect those data to help to predict the future as well. Yeah.
Yeah, fully agree. Mahmoud.
Yes, I want to ask if there is an specified template which used for determining the best location. I suppose that template may include, for example, a checklist which take in consideration all of the important or crucial points. Then shortly, is there a specific templates help the engineers to specify the best location for an PV system, for example, system?
Yeah, very good question. Thank you. I think each company has its own template. There might be some available on the internet. I could have a look and share it with you maybe next week. But it is a very important part of the design. I fully agree. But it also includes these considerations for the site, but also grid connection, availability, for example, and also environmental and social concerns. For example, the sites might be used already by some people for some uses, and then how it impact them, and what would be the preferred one. So yeah, I will have a look and try to share something with the whole team by next week. I just make a point with that. I will just mute you, Mahmoud. Yeah, checklists. Good point. Or maybe it is included already in the report we're submitting to Jetco.
I don't think there is a checklist in there. I have sent the draft to Hiba for input and what's missing, etc., etc. I also noted it down, so it would be good to include. Also, Stan, there is one question in the chat.
Yeah. What about extra consideration due to dust and how to clear the panels to get maximum power? Very good point also. So these are the site study very much related to the site, but again, a checklist for sites choice or decision would definitely include dust situation to avoid what we call the soiling. So proximity to cement industry or sand or different conditions can impact, absolutely can impact the generation of the plant. I think in using PVSys, you will also check quickly the soiling losses. But that's a balance to find in between. That should definitely be included in the site assessment. But it's also a balance to find between operation and maintenance and how often you're going to clean your modules and the actual dust that covers the modules. So I have seen PV plants in very dusty places, but that are just cleaned every single day or every 2 days or stuff like that. So it depends on availability of people around, depends on a lot of stuff. But absolutely something you will want to avoid, and that can have a huge impact on your total energy generation.
And this will be covered also in the operation and maintenance session, which is the last session in the training.
Absolutely. Very good. Good. Then we go quickly to the viability of the site. So when you have your understanding on what the site look like in terms of topography, underground, and water features. So you have your topographical, geotechnical, and hydrological studies that help a lot. You can assess if the site is viable or not, and in which extent. So as this picture shows here, a solar PV plant, a ground-mounted large-scale one, is not only about putting modules. You need to make sure that the delivery of material is easy. You need to make sure that you have enough space for the operation and maintenance teams, for example. So for large-scale plants, you need to make sure that you consider an office in there with basic things like maybe toilets, shower, and stuff like that. But that also takes some space. All of these features that take some space in your site. You might need to fence it, and you might need to have some kind of buffer between your fence and your site to avoid, I don't know, it can be anything, people throwing stones at your modules or stuff like that. So it's really a lot of considerations to take into account when you start doing the design. And of course, the access, also the roads in your site to just access different parts of the plant can also take space, and you make sure that you need to make sure that you have enough space to, I don't know, turn around, park your vehicles, and some kind of warehouse for the equipment, the spare parts and the O&M equipment. So well, all of that is also considered in the viability of the site at the end, because this one, for example, is looks quite bad in my opinion. So you have different under plants in the bigger plants, and they're quite spread, and it doesn't seem very efficient as using the land as it is. And of course you have this kind of picture, and that's also linked to solar PV becoming cheaper and cheaper, and then some people making plants that don't make sense anymore. Yeah, all of that is just like using the land as the best you can do there. Some site conditions might lead to expensive technical solutions, and that's also true with the underground. So we mentioned the geotechnical study before, and if the soil is tricky in many ways, can be too rocky or it can be too soft, then the solution for the foundations can be expensive also. So that's considerations to take into the viability discussion. And the grid connection is a very important one. So the distance from grid connection point, the grid connection, I'm not sure when or where it's going to be covered in the session, but you can connect your, again, we're talking about large scale plants here, but you can connect it to the closest substation, for example, or to an existing line with a loop in, loop out solution. But just keep in mind that, of course, long distance might be expensive. So again, you can step up your voltage for transportation. You can play with different medium voltage, high voltage solutions, but the transmission line will be expensive, and that's going to impact the system. We don't go very much into details in there. That could be a session in itself, but how do we also kind of assess the ability of the grid to take the power at this very location, and how much? It's a full assessment. It's a full study that is also needed. But I guess that's your everyday work as a utility, right? So that was ground mounted in building, which it's again not a huge focus in there, but you have different stuff to assess. The building can be new, can be planned, or it can be already existing. But you will also need to do some kind of structural stability assessment to make sure that if you use a ballast system like this one, for example, so you can see this solution, and then we just have like this kind of concrete plates in there that are used as ballast. And this is not random. The weight of it has to be carefully calculated according to wind loads and the location on the roof. Usually the corners are more exposed to wind, and then the ballast is higher. But all of that is part of a structural stability assessment. And then on the roof, you very often have a lot of rooftop elements like ventilation, aircon, whatever, a lot of stuff that also kind of impact a lot the design, because first, the area is not available, but it also, these ones are quite small, but like aircon is quite high, and it can cast shadow on the modules. That's also going to impact the generation. So all of that has to be taken into account when assessing a rooftop. And the big part also is a connection to the existing system. So on a rooftop, you will have to go down to ground level very often to connect to the existing system, to the existing distribution board, for example, for the building, or directly to the grid. And then that will lead to cable management. So where do you put your cables going from the roof to the ground? Do you put it outside? Do you put it inside? Is it safe? Is it viable? That's a big part of the assessment. And all of that will ultimately lead to an assessment of the yield of a PV system. So the yield is how much you will produce compared to how much you will install, so how much it's going to cost actually. And it's a bit the question we had before about the estimated area for 1 megawatt. It's kind of also part of the yield, but that's going to depend on many things like the size of the power plant, the characteristics, so the modules, the mounting system, the inverters, all of that. Obviously, that's going to depend on the weather or the climate conditions. So the irradiation, but also, as Michelle explained on Monday, your generation will also be linked to the temperature. So also on the ambient temperature and on the wind that will cool the modules and also impact the module temperature. So a lot of weather data in there. Eventual obstructions to solar paths, so meaning shading, can be shading from far away, like a mountain or a hill around, can be near shading, like a tree, a building, or whatever that's going to be on the way. And it can also be self-shading. So as you can see in the picture in there, when the sun is low, one row of modules casting shadow on the next one, and that's also going to impact your yield. Then obviously the orientation and inclination, and that was covered by Michel on Monday, and the technology. So which solar PV module you have, what's the efficiency of it, the mounting system, what the self-shade on that, the inverters and the other balance of systems, also your losses in cables and in transformers and in junction boxes or everything. So all of that will ultimately lead to the yield of a PV system and how we get it. Oh, we have a nice picture in there with sharing. What is that? Is it on one of the buildings? Whoa.
I think this is in Lebanon. The recent.
Is it you sharing name or?
No, someone else. But
no,
I saw this in social media. Yeah, this is in Lebanon.
Oh, it goes away. Oh shit. Nice. Yeah, I have a lot of pictures of failures in solar PV design. This one looks quite heavy. Jeez, that's crazy. Mahmoud, you wanted to comment on that? Nope. Thanks for sharing. Very interesting. So that's what you don't want to do. Example.
Also, Stan, there's a question in the chat.
Thank you. In practice, when should I use a east-west configuration? Well, different options. The first one is when you need power, but you don't have space. So the east-west configuration will be more effective in that sense. So you will install more power in less, in a smaller area, in a way. And also with low, closer to the equator. well, let me put it in another way. And again, that's something you will probably check in details with Michel tomorrow in the design session. But the problem with east-west, or the kind of theory problem, would be that your inclination and orientation is not optimal according to the sun. But again, that would mainly apply to locations far from the equator when the sun is lower. So then the south orientation would have more effect. But also in Norway, for example, then you have more generation earlier in the day and later in the afternoon, and then it actually matches. So your production profile is flatter, and it matches better with needs, with the load during the day. So that's also quite a good option. But in general, yeah, land constraint or constraint or not much space available, and also wind loads, heavy wind loads, for example. So your system is tighter with an east-west configuration and usually less exposed to wind, especially when the wind is north, for example. So that's again, well, you're going to lose a bit in yield, but you're going to increase your power. So you might actually end up with more generation, more energy at the end. But yeah, that will be covered tomorrow, I guess. Mahmoud, I see you have your hand raised again. Any question?
The shared video just before a few seconds, and the bad weather here in Gaza in the last few days open a question about the balance between the mechanical structure of the PV system, in the same time the economical considerations. I mean that we have to be sure that the mechanical structure is stable enough to be fixed to the earth, to the ground, or on the building, for example. But in the same time, we have to avoid rising the cost of the total system. How can we find the balance point in this case?
It is, thanks, that's a very relevant question, but that's a bit what every solar PV system is about, actually, finding the balance between cost and robustness in time and yield and everything. I guess, I mean, there are a lot of, what I presented before, there are a lot of solutions that are quite cheap and robust, and concrete foundations, for example, is one of them. The ballasted systems for flat roofs, if available and if correctly dimensioned, is also a system that is quite efficient cost-wise. So this, if I just go back quickly, but this system, for example, is not very expensive, and you can use whatever you want for ballast. Here they use kind of concrete plates and stuff like that, but you could use rocks in a way. So this can be quite cost efficient if the roof can take it in terms of weight, additional weight and stuff like that. So it's all about a good design to reach this balance between cost and robustness, and cost and yield, which is also important.
Yes, I just trying from my questions to pay the attention of my colleagues to reflect directly this important knowledge, reflect this knowledge directly to the ground. I mean, to find the solutions and pay attention for the crucial points. For example, these issues are related, for example, the stability of mechanical system, and at the same time, the efficiency or the economical efficiency. We have to take this point in consideration again. And at the same time, the limitations, for example, of materials. You know, we face a problem with the concrete here in Gaza, and limitations of essential substances need to construct a PV system mechanical frame, okay? And we have during this course, I recommend and advise myself and my colleagues to to try and find solutions and alternatives for the limitations here on the ground.
Yeah.
That's all. Thank you.
Yeah, that's but yeah, that's a very good recommendation. I do agree. In terms of, I mean, you can always dig a bit in what kind of solution is available according to your site. I don't have the details in there, but I've seen a plant, just to give you an example, a plant in Scandinavia. We couldn't touch the ground, so we couldn't dig, we couldn't pile, we couldn't screw. There was no way. And that was quite a remote place, so concrete was also not an option because we couldn't get the equipment there. And at one solution that we found was, which is quite interesting, there was an old railway around, and we could actually take whatever we wanted from there. So we used old parts of the railway as ballast for the mounting system. In some kind of cages that were directly mounted on the structure, and then we would put this old kind of metal stuff in the cages, and that would act as a ballast for that, and that proved to be quite efficient. That was built 10 years ago, and it hasn't moved, and very cost efficient solution. So I don't know. It's a site-to-site consideration. So that's something that would need to be more detailed according to where and according to how and what the situation and what are the conditions. But there are a lot of options, and you can be creative in finding a good solution there. So I don't know if you have a lot of rock around from some old buildings that have been destroyed, for example, that could be used as ballast, and that could be a way to kind of also remove these parts from the location to make it something useful. Yeah, there is space for innovation and creation. Is it what you're sharing now, Mariana? Is it the one for the report?
Sorry, my microphone was off. Yes, just sharing quickly what is included in the report. The idea there is that, Naeem, or you technical people, please fill in. But it's boxes, and you fill them with sand and rocks and whatever is available, and it's everything, sort of all the dimensioning and everything is included. So it should be possible to make with whatever is available. And then you put the panels on the top, and it's like a block, and then they can just be copied next to each other.
But that's exactly what I was just talking about. That was kind of boxes where you put everything you have in there, just to make it weight a lot, and that is used as ballast. Okay, no, I'm not aware of what's in this report. But this is exactly this kind of solution. So
let me just show the guys. Sorry, Stan.
Sure.
So yeah, this is from one of our previous projects in Somalia. I think this is the idea that we are talking about, and it is highly recommended for Gaza.
Yeah.
So you don't need to dig in the ground, and you can just use such baskets. You use stones or whatever you have at site. So this is the one we are considering in the technical report for the design systems for Gaza. And this is actual picture from one of our previous projects. Just an example.
Yeah, that looked exactly like that also with my old railway stuff.
Yeah.
Also a few questions in the chat, Stan, if you want to address them now.
Yeah, I see that. How could I make the maintenance and cleaning in the east-west system? I think that's, let me share again. Sorry. Here we go. I think that's the system you're talking about, Mohammed. This one is special because this picture, I guess, is from Norway, and in Norway we don't really do cleaning because we trains so much. So this is a bit specific, but in a lot of systems you can allow also for more distance in between rows for people to go in and just do the cleaning with usual water cleaning equipment and stuff. So that's quite easy in there. Next question was what is better to mount the panels vertically or horizontally in the same area? Depends a lot on your mounting system. We usually prefer, or I do prefer, because both options are very available, but I do prefer the landscape one, especially for ground mounted. And this is for the reason that Michel explained on Monday. So I don't know if you see my pointer, and if you remember, do you remember the junction diodes or the diodes in the module? So the modules are usually, it's less true now with the half cells modules and everything, but usually or historically they were connected in 3 different series with a diode that can just kind of cut off part of the module when it's shaded. And this would be kind of horizontal cut in a way. So this line of cells would be connected for one diode, and then this one, and then the third one would be on the top. And that means that if this module is casting shadow on this one, then that's okay, because the diode would just cut a third of the module in there. But if they're portrait mounted or vertically, another way of saying it, then the shading would be on this part, for example, and then the whole 3 diodes would be shut off. So the whole module would be off in a way. Is it clear? I guess it would be better explained with another, but Michel took this part on Monday, so I don't know if you remember, but the module is divided in 3 usually. So that's just a shading assessment, and it also applies for the dust. When the dust accumulates, it's usually you have a small ridge in there with the frame of the module, and the dust might accumulate just at the lowest part of the module, and then all cells of these lines will be shaded and then not producing. But that's if it's mounted this way, then only one diode on the 3 will be impacted. So that's a better yield at the end. I hope it's clear. If not, please raise your hand and I will try again. And yeah, no, okay, sorry. Good. Let's go back to Mahmoud. You had your hand up again. Is it a question or did you forget to put it down?
Sorry, I forgot to put it down.
Yeah, that's okay. No problem. Good. So back to the yield. Again, a natural way of putting modules, and that was also covered on the session on Monday, would be to put it south oriented so that you would cover the whole sun's path during summer and winter. One important thing to remember is that the elevation of the sun is obviously not the same in summer and in winter, and that's particularly true in Norway, for example, where some people in this school are located, where in winter it's very, very low, and sometimes, and in some locations in Norway, even not up at all. So it's dark parts of the year. But then you will have to find a tilt for your module, so the angle of the mounting, which will be optimal for the whole year, and not only in winter and not only in summer. So this is what we use design softwares also for. So you have a simulations hour per hour during 1 year, and at the end you get the yield of your PV system for 1 full year. And that's a better way of doing that than just picking a random day, for example. Yes, there's a question from Maria.
Yes, maybe you mentioned it and I missed it, but so is that also the way we would calculate what angle? I mean, if it's roof mounted, obviously we can't really choose the angle, but if it would be ground mounted, we could choose which angle the panels have, right? So how would that be calculated basically?
Yes, it is a balance to find. Everything is about balance always, but it is a balance to find between wind loads. So mounting your modules horizontally or vertically, for example, that would have a lot of wind loads, and then you would need a very strong system. It exists. We see that especially in the kind of mixing solar PV generation and agriculture, for example. So that allows agriculture in between, but then the system is way more robust and a bit more expensive. So you will need to find an angle that allows okay wind loads, so that is not acting like a sail in a boat, which is the angle would be low enough to avoid that, but high enough to allow for the rain to kind of wash the modules also a bit when it rains automatically. So kind of modules mounted purely horizontally at ground level wouldn't make more sense in terms of dust, and also optimizing the angle according to the sun's path during the whole year, so both winter and summer. So this is part of the design that will be covered tomorrow by Michel in PVSys. You have for every location in the world, you have an optimal angle. Like in Norway, that would be about 45 degrees. That would be the optimal angle for Norway during the year. So it's a mix of summer and winter. Lower locations in Europe would be 30 degrees, and actually the optimal angle close to the equator would be close to 0, even if in practice you will have to get some angle anyway for dust accumulation and stuff like that. So it's a big balance in between technical and mechanical concepts in there.
Okay, thanks a lot.
Then the shading will be quite important in the yield. And well, Michel mentioned that on Monday, but you have the bypass diodes in the module. So if one module, or actually a third of the module, is shaded, that will be just taken off the whole string, and then the bypass diode will allow the current to pass still, and then to generate and not cut the whole string. But still, it's going to have a huge impact on the generation. And all of these losses actually leads to the whole yield of the PV system. So if you consider the irradiation hitting your module, then you will have a series of losses that will lead to your energy, to your nominal energy. So sum of all these losses in a PV system, we call it PR for performance ratio. The performance ratio is in percent, so it's just the percentage of energy that goes from when you hit the module to the actual energy output in there. And it's usually about 75 to 90%, and 90% is quite high. Ground-mounted system, you usually lie around 80%, for example. But these losses, what are they? So you have the deviation from your nominal efficiency. So like if you buy a module which is let's say 250 watt peak, and remember the watt peak is in certain conditions, what we call the STC, the standard technical conditions, which is, anyone remember the session from Monday? Can you remember the 3 conditions of STC? Someone? There is first irradiation. Please, Nida. Yeah, irradiation at 1000 watts per square meter. Temperature, the cell temperature as 25 degrees Celsius. And the 1.5, exactly, the 1.5 air situation. That's very good. I don't know if Michel is still here, but he would be happy. So you will have deviation from that. So you won't be at STC, right? The STC is just for testing. It's just to compare different modules. But the irradiation, they will definitely not be at 1000, even if it's at 1005, that will differ. So that you won't be at the watt peak in there, and you will have some losses. There will be some soiling on the module. So your actual irradiation will not hit fully the cell because there will be some soiling on the glass of the module. The temperature will not be at 25 degrees, so there will be some losses or gains, actually, if it's colder. You might have some shading, and then you will have the different losses, electrical losses. So the DC wiring losses, so the DC cables are what's in between the modules and the inverters. You will have what we call the MPP mismatch that also Michel explained on Monday, the maximum power point mismatch, because your different modules and different strings will be at different power, but the lowest current will be the one setting the current for the whole string. So then you will have some mismatch in there. And we have some heat losses in the inverter. It's mostly heat, and the AC loss is also the same in the cables with the heat and everything. So all of that combined will lead to your global loss in the module, and that will lead to the performance ratio, the PR. This is one way of assessing the viability of a system, the PR. The other way is a specific yield. Here we go. So the PR is in percent. The specific yield is your actual energy generation per installed power. So that's kilowatt hours divided by per kilowatt peak in STC conditions. And usually per year. You can have specific yield per day, per month, but it doesn't make much sense when you consider the seasonality of solar PV generation. So we usually have it per year. And this is extracted from the software PVSys that you will see tomorrow. And you have here the specific production. So this is a random system. I don't remember. I think it's 20 megawatt in Ghana, in Africa. And you have the specific production, which is 1,600 kilowatt hour per kilowatt peak per year. So that would mean that for 1 megawatt, you would have 1.6 megawatt hour per year. So that gives a clear idea of the generation according to installed power. And the performance ratio. So performance ratio is just a sum of the losses. So it actually allows to compare two different systems in two different locations, for example, because the irradiation is not included in there. The performance ratio starts here when the module is on, and it's just a sum of losses, if you know what I mean. So you could compare a system in Norway and in Gaza, for example, and you might have kind of the same values if the system is well designed and if the losses are kept low. So these are the two key values that you get from. Again, you will need some kind of design software to consider the whole year and not just 1 hour or 1 day, and consider the seasonality of it. And here we come in the last part in the equipment choice. That's also going to be covered in the session tomorrow, but it's how do you pick the right solar module, for example? There are a lot of solar modules in the market, a lot of different providers. It is quite standardized. Is there a question? Nope. It is quite standardized, but you have different power ratings, different losses, different dimensions, the cell technology, and monofacial modules, bifacial modules, different frames and temperature coefficients. I will just open. If I may, here we go. One example. It is random. It is from Longi, which is one of the biggest tier 1 solar module provider, but it just to show you the data sheet of a solar module. It's always the same kind of. So you have the front page with the key technological features and the warranty. The solar modules have two types of warranty always. There is the product warranty. So it's usually 10 or 12 years now. It's getting bigger and bigger. And that is if you have an issue with a frame, for example, that is just, I don't know, or your glass is delaminating, or so that's the same kind of warranty that you would have for electrical products in your house, for example. So that's really about the product. And then you have the generation, the power output warranty. And And this is, so the modules are gonna degrade in time. That's the whole physical feature of solar cells. So it does, unfortunately, not get better in time. It ages, but it ages differently according to the manufacturer, according to the cell, and all of that. So all manufacturers have to provide a warranty on the aging, on the power output. And it usually looks like something like that. So this is the curve you see here. According to technology, you might have a loss at the very beginning, the very first hours of exposure to sun, and it's usually no more than 2%. So in years, they say that year 1, you have 1% loss. So you go directly from 1% to 99% of efficiency of the module. And then in time, they will warranty a degradation rate. So this one, for example, Longi, so this company, for this module, they will warranty that after 30 years, you still have 88.85% of the power in each module. So if your module is 650 watt peak, for example, after 30 years, you can come and measure it and you will still have that. If not, you can contact them and they will replace it. This is the power warranty, so which is quite important to check in the data sheet. You have very often each module come with different power. This one, so this is the module name in a way, the module denomination. This one will go from 635 watt peak to 670 watt peak. And this is because the cells during production, they come with different efficiency and then they rank it and they put it in different modules. Of course, the cost will not be the same. The price for the 635 and the 670 will not be the same because the efficiency is not the same. The efficiency is just the power of the module divided by the surface of the module. So for this one, for example, the efficiency for the 670, the efficiency is 24.8%, which actually can directly be translated to 248 watts per square meter. And for this one, it's only 23.5. So this is a less efficient module. For the same dimensions, you have less power. So this is something, when you purchase, this is something you can check depending on your requirements. If you need very efficient modules because you need a lot of power, but you don't have enough space, then you go for the highest. And this is just for this one. Longi will have different denominations or different categories of modules, also going in lower. So you might have the LR866 HYD 615 to 640, for example, which is probably going to be cheaper. Yeah, here something important also, you have the power tolerance. Again, you're buying a 670 watt peak module, but the cells, the technology for the cells is not as precise as that. So the guarantee that you will have 670 plus 3%, plus 0%, 3% maximum. So you might have a difference. You might actually get a 671 watt peak module or 670.5 watt peak module when you actually receive it. But they warranty that you will have more than what you purchase. So you will have more than 670 and maximum 3% more. In the old times, they would warranty plus minus. So they would actually say plus minus 2%, for example. So you might end up with a 668 watt peak module, but it's not the case anymore. So it's just a positive power tolerance. And in the data sheet, so you will also get the dimensions. Very often you get the location of the holes in the frame for the clamping or the mounting. So that might help a lot also in designing your mounting system and how it will actually look like with the tolerance. So everything needed for the mechanical assessment. You get the glass, you get the frame composition, you get the weight of the module, 23.5 kilos for this one. the dimensions. Sometimes, not always, you also get some information on the packaging. So this one is 36 pieces per pallet, and then you have the container, 720 pieces per 40-feet container. You get the electrical data, so the maximum power, the open circuit voltage, so that's the maximum voltage in there, the short circuit current, as again, the maximum current in there, and then at MPP, so the maximum power point. You had maximum power and the voltage at maximum power and the current at maximum power. And also important, some ideas of the standards, but it's often the same, but the temperature coefficient, the temperature ratings. So this is, as Michelle mentioned on Monday, this is the temperature correction. So for this one, for example, you will get the impact on each degree Celsius, the impact on voltage, impact on current, and then the impact of on the maximum power per degree from the 25 degrees of the STC. So you will see that some modules are more tolerant to high temperatures than others, for example, and then limit the losses. That might be relevant for Gaza also in some extent. And you also have the mechanical loading. This is a standard 5,400 pascals and 2,400 pascals for the front and the rear side. This is quite standard, but some of them are also more resistant for different applications. Yeah, so this is just an example from LONGi, but all will kind of look the same. So you have all of this information in data sheets for all modules. I see that there is a question in the chat. What is the relation between the size of the module and the efficiency? I will just repeat it quickly. So the efficiency of a module, this one in percent, this is the surface in square meters. This is the power divided by the surface. So you can do it yourself quickly, but if you do 2,000 or 2.4 meters times 1.1 meters, you will end up with the surface of the module. And then you divide the power of the module, this one is 670, by the surface in square meters. And you will end up with this number in watts per square meters that converts into this in percent. So this one is 248 watts per square meter. So that's 24.8% efficiency. Yes, Mohammed, please.
Hi, Stan.
Hi.
My question is about the efficiency. You know that the efficiency is calculated for 1 square meter.
Yeah.
So why in this data sheet from LONGi, and I think they took the same technology in manufacturing the modules that's output power is lower than 635 watt. The efficiency is 23.5, I think. When they manufactured one, the efficiency is going more. Where is the relation? They used the same technology, but when they enlarged fuel, the efficiency is going up.
That's a very good question, and it's directly related to the manufacturing process of the cells, not of the module. So again, the manufacturing solar cells is actually not very precise technology in a way. So they end up with cells that are slightly less efficient than what they plan and slightly more efficient than what they plan or what they're trying to do. And then they rank it. And based on that, they make modules that are slightly less efficient and slightly more efficient. Again, the efficiency in PV modules goes from, let's say, 20% now to 25, 26 maximum. So this one, for example, is a very efficient module, but the difference is very limited. It's a very slight difference between a module of 635 watt peak and 670 watt peak, but it's just the cells. So they've put the less efficient cells they got out of their manufacturing process in this one, and the most efficient cells in this one, and everything in between, just so that they end up with a module with this rated power, if it answers your question. They cannot. It's silicium based, but they cannot. They make cells and then they test it in a way. They cannot make a cell which is rated at a certain power or certain current and voltage. So they make cells the best they can, and then they classify it, and then they make modules according to it. Any more question on the module data sheets? Okay, I think we're in time. We just finished. Here we go. And then the inverter, I didn't go into details, but that's good because we're already running out of time. But that's again, I can share the PVSys download link, of course. Let me just do that now, and then I conclude on the inverters. So PVSys has a website.
It's fine. Mariana just shared it, Stan. You can go ahead in your presentation.
Okay. Did you know? Oh yeah, awesome.
Yeah, just put it in the chat.
Oh yeah. Oh, I thought Marianne wrote that. Okay, I got confused. Yeah, and that's going to be the same for the inverters. And again, the picking an inverter will also be covered tomorrow during the design session, which I highly recommend you to attend because that's one of the most relevant. It's really about hands-on design. But as Naeem covered on Monday, so you have different types of inverter. You have the central inverters that are usually massive and including transformers and everything, and then you have a lot of strings, maybe hundreds of strings coming into one inverter. You have the string inverter, which are these boxes in there on the picture, which are more easier to mount and also have more granularity. So if one inverter is going down, then the others still function. And you also have the micro inverters, and the micro inverters is actually small boxes that you install on the back side of the modules. Can be for one or two modules, and that optimizes the AC power of per module, kind of. So it has pros and cons, but picking that is also about the design and the site condition. So that different stuff you have to check when you're picking an inverter is of course the whole design, but also the number of inputs and maximum power point trackers that needs to fit your preliminary design and your site conditions. And the output voltage is a very important one. On buildings, for example, very often you will probably connect to the electricity system in the building, in the DC board, so directly at 400 volts, for example, or you might need some transformers for bigger plants to just step it up, step up the voltage to medium voltage or even high voltage according to the size of the plant and the grid connection options. So picking an inverter is a bit more tricky and a bit more related to your design, and that will be covered tomorrow. Good. Any question now? I will take everything, all kind of questions you have. Mahmoud, I see you have one more.
Yes, we find in the data sheet a lot of informations and data. Okay,
yeah.
Which are the key informations or data which we have to take in consideration for the preparation for the designing phase? And for example, and I think that the dimensions of the PV cell we should need this information or data in designing the mechanical structure. Okay, what are the other important or significant key informations which we have to take in consideration in the designing phase?
Yeah, you would have to just mute you. You would have to take into consideration the dimensions, obviously, of the module, the efficiency, the cost, which is not in the data sheet, but that's a huge, very important information in there. The cost of the module, and that will also kind of vary a lot according to volume and according to efficiency and a lot of stuff, and the technology in a way. So this one's, for example, as you can see, it's also mentioned in here. This is half cells. So the cells of these modules are cut in half, and that also allows for more granularity and more efficiency in shaded conditions. That's something that might be important for your plans. I guess at some points, what really matters is the power of your module. So one module, so that would be kind of directly related to the efficiency, the dimensions, and the warranty. Because yeah, you will find a lot of different modules with a lot of different efficiency at very varying costs and everything. But at the end, the dimensions are quite similar. So the cost will be a very important value in there. The cost and the power. There is a question on the data sheet of a double phase bifacial solar cell. Whether bus bars less cells are better and when they should be used. Yeah, all of that. Well, first of all, bifacial will be definitely or it is already the future. Let me see if I can find one data sheet. Well, we can try Longi again. Currently, I think now this year is about 80% of the modules that are produced are bifacial, not because we want to use the bifaciality of the modules in every project, because very often it's not possible, like a lot of rooftop installations, but just because the industry is getting there. So the manufacturing industry of solar modules is really getting into bifaciality, and that's the new normal in a way. So even let's see, why is it in French? This one for homeowners support. So what is that? Commercial, industrial. They have their modules somewhere. This one bifacial. Oh well. While I'm looking, I can stop sharing. Try to multitask and keep talking when I'm looking for that. Yeah, so the bifaciality is also, so it's coming big, it's already there. Everything is kind of bifacial, or if it's not now, it will be in the next 5 years. The bifaciality gains are hard to quantify still, because it depends on a lot of stuff. So first, it's very much linked to the diffuse irradiation, as Michel mentioned on Monday. It's also very much linked to the reflected irradiation. So whatever light comes into the ground and is reflected by the ground to the back side of your module. And this is related to albedo. The albedo, I don't remember if Michel covered it, but that's the ratio of light that is reflected against the light that is absorbed. For example, snow or ice will reflect a lot of light it's going to be about, I don't know, 60% maybe, 60-70%, while grass or water, actually, it's a surprising fact, but will actually absorb a lot of light. So then the pure bifaciality gain will be very much dependent on the type of ground you have, but also sometimes on the weather conditions. Because an example from Norway, but also when in winter, when the ground is covered in snow, the bifaciality will be much higher than in summer when there is no snow. A rainy day might increase the albedo because the water on the ground will actually act like a mirror, while a sunny day will be less albedo. So everything like that is it is actually harder to quantify than just the irradiation from the sun. So all providers, I'm still looking for a module, but they will provide you with a high-level assessment of the bifaciality of the module. Here we go. Maybe this one might center. Yep, I got one. Share again. Yeah, so that's another one from made in USA. That's weird. Anyway. So where are their bifaciality gains? Oh, but actually the one I had before was already. Yeah, that's what they're gonna put in the bifaciality gains there. So they will refer to one of the rated power in there. So from this one goes from 530 watt peak to 550, and they usually take the one in the middle. So this would be 540 watt peak. So this one refers to the 540 watt peak, and then they will provide different values for different power gains from the rear side, from 5%, 10%, 15%, 20%, 25%, and then you will have the Pmax per watt and watt, and also the different electrical characteristics, and that's something you're gonna indicate in your design software, like PVSys, to kind of consider the bifaciality gains according to your design, according to your ground conditions, and according to your tilt and orientation and everything. But to be fully honest, there is no design software yet that really assesses in details the bifaciality gains of any solar PV plant. It's a bit too physically complex. So you get ideas, but it's very rough. The bus bars, that is, let me try another thing. We just look for pictures, because the module production is going very fast in very different directions. But that is what the typical monocrystalline cell was actually looking historically. Yeah. So here you have the cell, but then you need to collect the energy produced by every cell. And for that, you have a grid of metal, because it can be different materials, but you have a grid of different metals on the cells or on the backside of the cells. I mean, there are a lot of different technologies for that. And what you can see in there, the lines in there, that's what we call the bus bars. So that's the biggest part of the grid that is integrated in the cell to collect the current and put it in the string that is or the series that is actually one bypass diode in there. A lot of different technology in cell production and module production now, but some have found new ways of, to put it simply, new ways of not using bus bars or putting inside the cell so that it does not impact the light coming into the module. This one, for example, this is a small line, but this line is not a cell. I mean, it's on top of the cell. So that means that this area of the module is not getting light directly, or is not converting light to electrons. So this is a loss in efficiency. So in the race of increasing efficiency more and more and more and more, there are new solutions coming and putting bus bars in different places. So that increases efficiency, but also increases the cost. And again, the evolution of PV modules manufacturing are crazy these times. I hope it answers a question some way. Any more question? I'm looking at the chat now. That's okay. It's more about PVSys. No, PVSys unfortunately does not exist on a Mac, so you would have to kind of emulate Windows on it, unfortunately. Mohammed, I think you have a question, or at least you have your hand raised.
Thank you. I want to ask, because you are going to dig in the cell technologies.
Yeah.
I want to ask about the N-type and B-type. And there is another question, but I don't know if there is time. What about the PERC technology and the half cell?
Yeah. Yeah, I can try to answer. Sure, please go ahead. You have any?
Starting with the N-type and the B-type, and which is better now?
Yeah, I guess now every new modules, they're N-type. Now I won't go into physical details of I mean, producing silicium and cells from silicium. I don't think it. What I can refer to, and I think that would be an interesting reading for you all, is I will share the link, the ITRPV report. This is a German institute that is really looking in details. Yeah, the one. I will share the link also on the chat, so you can have a look if I find it. They're looking at trends in solar cell and solar modules manufacturing, and what's coming and what, because there is a thing with what's mainstream now. There is also a trend on what's the most efficient, but that's also the most costly, of course. So that's actually not what is the most sold in the market. So you always have to find a balance between very efficient modules. Is it really what you want, or kind of mainstream modules, which are more affordable and also produce quite okay? So, well, it depends. It's a case-by-case study. But this is this report. Here it is. I will just share this link here. This goes into details in this kind of questions about what modules are available and what's the technology that is coming in 5-10 years in N-type, P-type, PERC, TOPCon, all of these questions. I think the question Maria just asked is a relevant one. What are you going to be able to import into Gaza in the near future? And I guess it's not going to be the latest, very expensive modules, and that wouldn't make sense either. So I think what you need is volume and efficiency, cost efficiency. So something that is producing, which is not at the top of the market, because that's not exactly what you need. But that's a question I want to ask now in plenum, if someone can answer me. Is it what are you currently able to get into Gaza in terms of solar modules? Is there any restrictions, of course, but any clear restrictions on equipment, or is it mostly financial restrictions, or what is the situation now? Nobody?
I think I can comment quickly on this, Stan. Because of the situation in Gaza, actually, it is expected that there will be 2 types of equipment that will access Gaza soon, after they announce the new committee that will manage Gaza. that is expected to happen today or tomorrow. First type is the one from donors. So for this one, the team there in Gaza will not have any flexibility, you can say, to choose or decide. It depends on the donors and what they can send to Gaza for modules, inverters, and others. The other type is for commercial use, and this depends on the local distributors and the companies and the agreements that they have with the manufacturers that used to access Gaza before. So this is the point. So I'm expecting what they used to have before, they will continue having it from commercial point of view, and the other one that will come from donors.
Mm.
Yeah.
Yeah, makes sense. Thank you. Good. I will have to leave in 8 minutes. Do you have any more questions? Yeah, there is one on the chat. When we're comparing multiple solar panel brands, including both well-known and less familiar ones, and the IEC compliance, warranty term and pricing are probably similar. What key parameters do you rely on to differentiate quality and decide which option to select? There is one thing that is very important is the manufacturer. And I think that's going to be a good conclusion, but all manufacturers will provide warranties for 12 years, 30 years in power warranty, power output warranty. But what you want to make sure about is, are they going to be there in 30 years? And there is no way of knowing that. I mean, companies can go bankrupt and any day, anytime, whatever. So one thing which is quite important is to pick what we call tier one module providers, and this is an actual list which is being updated every semester, I believe, every quarter, or I don't remember, by Bloomberg New Energy Finance, and it's not about technical quality, it's about financial viability. So what are these companies? What is the state of these companies in terms of financial health, in a way? And they provide a tier one list, which is just listing the best companies in terms of results and sustainability financially. I mean, so these are the ones that should actually must probably be there in the future if you would have any complaints to fill. And this is quite important to just not pick any random manufacturer, because you don't know if they're going to be bankrupt in 6 months or in 2 years. So this is one thing that can help differentiate different providers, for example. But to be honest, at the end, when you do your preliminary design, as you will do tomorrow with Michel, you will have some idea of what you need in terms of power for the modules, and then based on that, it's going to be a cost question. So what can you get at which cost? That's in the tier one provider. So that's going to be the final conclusion. Yeah, just trying to look at that. Given the unique and high density operators maximizing the energy yield per square meter, we need to focus on high efficiency solutions. Yeah, I do agree. And for that, it's not only about efficiency of the equipment, but also about thinking about innovative ways of putting solar PV. And as mentioned by Naeem before, solution that can allow dual use, like solutions on top of tents, solutions on top of crops or whatever. That's also going to be highly relevant for Gaza, because then it's not areas that are just dedicated to solar PV, but that are used for different stuff, including solar PV. Yeah, and then we do the picture, and then I will let you go for your day and focus on tomorrow's session. So if everybody can please turn on their cameras for the picture, that would be good. Let's start myself.
Yeah, and a reminder to download BVSYST before the tomorrow's session, because it is the main tool that will be used by Michel tomorrow.
I'm not sure who
Naeem.
who mentioned at the start to turn on the cameras, but if there was a wish, then everyone, please turn on the cameras if you manage.
Yeah, because Engineer Mahmoud mentioned that they will take screenshot for PR. Engineer Mahmoud, are you here?
Yes. ايوه نعيم معك انا. مش هبه الموضوع عندك موضوع السكرين برنت سكرين.
معاي. Yes. Yeah. I will take the picture.
طيب.
Okay, guys, can you quickly turn on your cameras, please?
وين بقيت الشباب؟ بقيت الشباب المهندس هشام، ابو المجد احمد، اللي مش ممشط شعره بنظبط له اياه على الفوتوشوب. عم الشاب تمام؟ هبه
يلا
it's
okay,
okay.
just a minute. Okay. Yeah, okay. Okay. خلصت أخذت. يعطيكم
It's
ألف
okay.
عافية.
تمام،
Thank you so
جاهزين؟
much.
اللي يعطيكم العافية
Thank you
جميعا،
so much.
بالتوفيق. See you tomorrow إن شاء الله.
إن شاء الله.
ما تنسوا
Thank you.
البيبي سيست كمان مرة.
Thank you very much for today. See you tomorrow.
باي باي. السلام عليكم.